Hello, welcome back. I'm John, an old YouTuber and PC gamer. I think I will do one more, but it's a little bit late. It's 10 p.m. and I have people living around me, my small apartment. But let's try to do the Intel 4040. The Intel 4040 CPU. This Federico Fakings is still uploading, and the Fairchild Semiconductors. I was just to download 20 or 30 PDF. I have like 30 web page open, so I have to save this before I go to bed. But let's do the... Yes, this is the Fairchild Semiconductors. Let's close that. Let's do the Intel 4040. And we need to do what 4-bit computing, what 8-bit. We need to do that. But this will take this will take many hundreds of hours, so I'm not worried about that. I have time to do it, so this will take many weeks and months to do. So, but this is my day number one. It's day number one. It's just... I think this is 6 pages. I think we can do this in less half an hour. But this is this is the final one for today. Then I will upload this and download all this 30 PDF. So let's get started. Let's get started.
Intel 4040. Intel 4040 Intel C4040.jpg. The Ceramic C4040 variant general information launched 1974, discontinued 1981. 1. Common manufacturer, S. Intel. Performance max. CPU clock rate 500 kHz to 740 Hz, data width 4 bits, address width 12 bits, multiplexed. Architecture and classification technology node 10 instruction set 4-bit oriented physical specifications transistors 3,000. 2. Package S 24-pin DIP. Socket S DIP 24. History: predecessor Intel 4004, successor none. Intel discontinued its 4-bit processors after the 4040. The Intel 4040 microprocessor was the successor to the Intel 4004. It was introduced in 1974. The 4040 employed a 10 silicon gate enhancement load PMOS technology, was made up of 3,000 transistors, 3, and could execute approximately 62,000 instructions per second. General performance, bus layout and instruction set was identical to the 4004, with the main improvements being in the addition of extra lines and instructions to recognize and service interrupts and hardware hold/stop commands, the latter allowing operator-controlled single-stepping for debugging purposes, an extended internal stack and general-purpose index register space to handle nesting of several subroutines and forward/or interrupts, plus a doubling of program home address range. Contents. New features. Extensions. Characteristics. Designers. New support chips. Notes. References. Further reading. New features. Interrupts. Single stepping plus both hardware and software halting. No power standby, Note 1. Extensions. Instruction set expanded to 60 instructions, 14 new instructions added to existing 46, mainly concerned with handling interrupts, halting /single stepping and ROM bank switching. The ceramic D4040 variant. The plastic P4040 variant. I4040 microarchitecture. NB. The data bus is also used for addressing Intel 4040 DIP-chip Pinute Intel 4040 registers. Program memory, ROM, expanded to 8 kilobytes, 13-bit address space, using bank switching. 4004's original single chip select expanded to 2 mutually exclusive lines, Node 2. Registers expanded to 24, 8 added to the 16 existing 4-bit wide general-purpose index register set, mainly for us with interrupt processing, Node 3. Subroutine /interrupt stack expanded to 7 levels deep, using dedicated internal registers, Node 4. Characteristics. Data bus, 4-bit. Address bus, 12-bit for ROM, multiplexed on 2 data bus. Addresses took 3 bus cycles to transmit, same as in 4004, effectively 13-bit with use of bank switching commands, effectively 10-bit or 8-bit for RAM, 8-bit direct address plus 1 of 4, i.e. 2-bit equivalent, bank select. The additional 256 status memory locations required use of I/O commands to read or write, from an overall 8-bit address space. Voltage, -15 VDC. Operating frequency, 500 to 740 kHz main clock, 2-phase, overlapping, 62,500 to 92,500 8-clock machine cycles per second, each instruction requiring either 1 or 2 machine cycles to read and execute, meaning a raw average of 62 kIPS at 740 kHz with an equal mix. Node 5. Performance. Claimed execution time of ~850s to add to 32-bit, 8-digit BCD numbers, or around 1,175 such operations per second and approx 10 machine cycles per digit pair. Node 6. Designers. Federico Fagin proposed the project, formulated the architecture and led the design. The detailed design was done by Tom Innes of Bristol. New support chips. 3216 and 3226 4-bit parallel bus drivers, Node 7. 4101 256x 4-bit static RAM, Node 8. 4201 clock generator, 500 to 740 kHz, using 4.000 to 5.185 MHz crystals. 4207 general-purpose 8-bit output port. 4209 general-purpose 8-bit input port. 4211 general-purpose 8-bit I/O port. 4265 programmable general-purpose I/O. 12119070605040302010. Bit position. Accumulator condition code C carry flag index registers R0 R1 index bank 0 R2 R3 R4 R5 R6 R7 R8 R9 R10 R11 R12 R13 R14 R15 R0 R1 index bank 1 R2 R3 R4 R5 R6 R7 program counter pushdown address call stack PC1 call level 1 PC2 call level 2 PC3 call level 3 PC4 call level 4 PC5 call level 5 PC6 call level 6 PC7 call level 7. 4269 programmable keyboard /display. 4289 standard memory interface, replaces 4008/4009, Note 9. 4308 1kx 8-bit ROM plus 4x 4-bit IO ports, Note 10. 4316 2kx 8-bit ROM, Note 11. 4702 256x 8-bit EPROM, Note 12. Notes. 1. Essentially a side function of hold/single step. All internal processing would be suspended and most of the chip hardware put into a low-drain high-impedance condition. But the machine cycle clocks would be kept running for the benefit of external devices, including any interrupt controllers which would be needed to back the chip back up, that relied on them to stay in sync. 2. RAM space remained unchanged from the 4004, as did the inability to run programs from IM. 3. Only 16 of the so-called index registers, which operated and were usable in a way that would be more familiar as general-purpose registers in a modern CPU, where an index register has a much more specific application to memory addressing, could be accessed at any one time with a particular bank switch command being required to swap in one or other bank of 8 to logical registers 0 to 7, and registers 8-15 remaining continually accessible. The idea was that any mission-critical context should be kept in the first 8, as when an interrupt occurred it would not only push an exception handle address onto the stack but also switch index register banks, automatically preserving that state until the handler returned control to the normal program flow, assuming, of course, you hadn't already deliberately swapped banks in order to make use of the additional internal memory space. If an interrupt routine wanted to make use of the latter 8 registers, it was up to the programmer to first save any data held in them to another location, and then restore it before returning from the routine. 4. By default only one level of interrupt was supported, as further servicing was disabled once an initial interrupt was acknowledged and only re-enabled on RTI, essentially allowing 3 levels of subroutine stacking within an interrupt itself occurring within.
Yes, we probably don't need to record all the notes, but let's just do it. We have recorded 13 minutes, so we got 6 minutes left. But let's keep this, just keep this video in one part, and I will stop when we have like 1-2 minutes left, because I like to say good night.
A 3-deep subroutine, but detection could be forced back and with a specific command. 5. This may not be entirely accurate, and is based on the 4004 characteristics. Some of the added instructions may require additional cycles to execute, especially any external register stacking required for interrupt handling. But it is not made clear in the documentation as to whether this is the case. Hold/step are special cases which naturally take potentially many millions of cycles to execute. But as these essentially occur outside of the usual program flow, they don't count for speed. Calculation. 6. Likewise, based on claimed 4004 performance, 850S is a somewhat rounded off figure claimed in an early Intel brochure and may not be particularly precise, but the total execution time works out to approximately 79 or 80 machine cycles, which fits neatly with either 10 cycles per digit pair, 9 cycles per pair plus 7 for setup and any necessary post-processing, or 8 per pair plus 15 extra, etc. The actual instruction mix wasn't specified, so without both source code and a list of instruction execution times it's impossible to be sure. A more efficient addition routine might have been possible on 4040 vs the 4004, but the extra instructions don't suggest any obvious method for achieving this and appear to be focused on addressing earlier chips' more obvious shortcomings, e.g. a lack of interrupts and haltability. 7. Provides high current, 25 mAh, handling capacity for external I/O devices, Alleged lie intended solely for use with the 4289, but design appears fairly generic and may be adaptable to bear 4004/4040. 8, i.e. combining the main storage of 4002 into a single individually selectable chip, viewed with neither the 4-bit I/O port nor additional 64 words of I/O command accessed status memory. As it has a dedicated 8-bit address bus and 2 separate 4-bit data input and output buses, the 4101 is intended only for use as a downstream peripheral of the 4289. This is further emphasized by the SRAM's claim to be used for writable program memory, something not achievable by a bare 4004 or 4040. 9 allows connection of standard memory, 8-bit parallel data and / or up to 12-bit parallel addressing, the latter in the form of 8-bit address plus 4-bit binary chip select, and devices to the 4004 or 4040, as well as the use of RAM as program memory. The 4289 can be installed so as to appear like a regular 4001 ROM to the processor regardless of what's connected on the other side, furthering the illusion. It also provides same 4i/O lines that a 4001 would offer. A 4040 making use of two 4289s. Could offer various combinations of ROM and RAM in 2 CAPE segments up to 8 kilobytes total with a relatively simplistic segregated addressing scheme and a small number of 4101s and 4308s. For example 3x4308 and 8x4101 for 6 kilobytes ROM and 1 kilobytes RAM. 10 directly replaces 4 separate 4001s with a single chip, including being available in 4 metal variants that respond to logical chip addresses 0 to 3, 4 to 7, 8 to 11 and 12 to 15, simulating 16 original versions of the 4001. 11 intended for use downstream of a 4289, as it presents an 11-bit parallel address input bus and separate 8-bit parallel data output bus, as well as 3 binary-coded chip select lines, thus allowing provision of up to 16 kilobytes ROM with an addressing scheme incompatible with the 4004/4040 on several different levels. Alt have only 2 4316s, thus 4 kilobytes of ROM, or 1 4316 plus RAM, can be directly addressed by a 4289 without additional hardware and / or special programming techniques. 12i UV raised rather than electronically, and is again intended for use with the 4289, as it has separate 8-bit parallel address input and data output buses. References: 1. CPU history. The CPU Museum. Life cycle of the
let's stop.
CPU.
Very good. We've got 1 minute left. It's too late to record more because I have people living around my apartment. It's 10:20 p.m. Many are going to work tomorrow, Monday. I don't do that because I am on pension. Yes. But I will charge the camcorder. Then I will continue tomorrow. Then I will download all this 30. Got 30 web pages open here. So, and this video is about Frederico Faggings is almost finished. Then the Fairchild semiconductors. Then we got the old Intel 4040. So I did record a lot today. So I will charge the camcorder. Then I will continue tomorrow. And now the power is red. So good night.